Jai Hind to all. This is Dr. Shivani Agarwal. So today's my topic is sleeping Barber problem. This is the topic of the operating system. The code of the operating system is KCS 401. So let's start the topic. So we start the topic from the process synchronization. This is the first slide. What is process synchronization basically? So when two processes run in the system, so there are two modes. First mode is the serial mode, second is the parallel mode. What is serial mode? What is parallel mode? If all the process executing one by one, not all the process executing concurrently, all the process executing one by one. So one process start the execution, then at that time no other process go for the execution state, but after the first process execution is completed, the second process go for the execution state. So this is the serial mode. When we process the one process, then the another process going for the execution state. So this is the serial mode. Now what is parallel mode? Basically many processes run simultaneously. When the many processes run simultaneously, so it creates a big problem. That problem occur due to the some type of processes. Those processes are cooperative process and the independent process. What is cooperative and what is independent? Basically cooperative is what? When one process affect or can be affected by any other process. When one process executed and that process demands some another resource, that resource hold by the any other process. So these are the cooperative process. Suppose there is a one glass and I also want to see the movie, and one more person come sit behind me, and that also needs a 3D glasses. So when I wear the glasses, at that time that person just wait for the glasses. So these are the cooperative process that when I wear the glass, at that time the second person hold the glass, wait for the glass, because I am holding the glass at that time. So this is the cooperation, that first I see the first part of the movie, then you will take the glass from me and you just watch the movie after I see the first part. When you see the first part, then please give me that glass, and so I just see the second part of the movie by wearing the glasses. So these are the cooperation between the two resources. So this is the cooperative process, when the process can affect or affected by some another process because they share the resource, anything, either resource, variable, file, anything. So these process known as the cooperative process. Now what is independent? Independent means we can't share anything. So all the process run executed with own resource, that is not dependent with any other resource. So this is the independent process. So there is no effect from another process from the executing process. So this is the independent process. Now what is critical section? Critical section, it is a code segment. Basically it is a code segment. Each process a code segment called a critical section, where shared resources are accessed by the various cooperative process. I already explained the cooperative process. So you know about the critical section from the cooperative processes, because cooperative critical section is what? Critical section is a code segment. This is a code segment. So that code segment known as the critical section, and in this code segment the shared resources are used by the various cooperative processes. So this is very simple definition of the critical section. When one process is executing in its critical section, so at that time no other process to be allowed to execute the critical section. That I already explained with the 3D glass example. When one person wear that particular glass, so no other person at that time wear that glass, because we have only single resource and this resource is a cooperative resource. So this is the critical section. Now what is semaphore? Semaphore is an integer variable. Semaphore is an integer variable shared among multiple process. It's shared among multiple process. The main motive of the semaphore is the process synchronization. This concept adapt the various concept of the process synchronization like as holding, like as waiting, like as locking. So these are the basic concept of the semaphore, and it acts as control for a common resource because due to the cooperative process, and this follows the process synchronization. So obviously this follows the cooperative process that use the concept of the cooperative process. And the process of using semaphore provide two operations. There are two operations of the semaphore. There are a very useful operations of the semaphore. First is wait and second is signal. Wait, what is wait? Basically, the wait operation is used for decrement the value of the semaphore. When we use a wait operation, that means always decrement that particular value by 1. And what is signal? Signal used for increment the value. So, these are the two basic operations of the semaphore, one used for the decrement, one used for the increment. Wait used for decrement and the signal used for the increment. When the value of the semaphore is 0, what it means? What is the basic purpose of the 0 if the value of the semaphore is 0? So, at that time, when the value of the semaphore is 0, at that time, any process that perform a wait operation will be blocked, because it is always 0 and wait operation is just decrement that particular process. If the value is 0 at that time, so it is -1. -1 means that is negative. So, that blocked that particular process. So, and when used for the signal operation, so that particular signal operation perform the operation. So, this is the basic concept of the semaphore. Now, these what is the problem? This is basically classical problem of the process synchronization. So, what is the problem of the sleeping barber? This is a sleeping barber problem. So, what it is? What is sleeping barber? Sleeping barber is a classical problem of the process synchronization. In the sleeping barber problem, there are some hypothetical things that we have to use, like as one barber chair, and the number of chairs are used for the customers. Customer are in the waiting state for wait for the hair cutting. So, these are the basic concept. Just we have to imagine that we have a we just want to cut my hairs and we want to go to the barber shop. So, there is one barber. This is the hypothetical concept of the sleeping barber problem. So, these are the major characteristics that we have to use, that there is one barber chair and n number of the waiting chairs for the customer. So, these are the waiting chairs. This is the sleeping barber and this is customer. Customer is leaving when the chairs are full. Customer is leaving when the shop is closed. Customer is entering when the shop is open. Customer is entering when the waiting chairs are empty. So, there are the some concept. Let's we discuss the basic conditions of the sleeping barber problem. No. Now, first condition, if there is no customer present, then the barber sit down in the barber chair and fall asleep. This is also a very hypothetical condition, that if there is no customer for a long time, so the barber bores at that time and that barber sit that particular chair and sleep. So, this is the first condition. Second condition is what? When a customer arrives, so he has to wake up the barber because the barber is asleep. So, customer arrives, so he wake up for the hair cutting to the barber. If there are many number of customers and the barber is cutting a customer's hair, so that particular customers, or those are the customers, those are present in, instead of the customer that is already sit on that particular barber chair. So, these customers are the waiting customers. Then remaining customers wait if there are empty chair in the waiting room. If there is no empty chair in the waiting room, then customer leave that particular barber shop. So, this is also option. Otherwise, he is standing in the barber shop or outside with the barber shop. So these are all the conditions. Now the next condition, if the new customer arrive in the barber shop and there is no empty chair in the waiting room, so the customer leave the shop, I already explained. Now last condition, the customer who came earlier will come back and check the barber is free. If the barber is free, then the customer sit in the barber chair because there is no customer at that then the waiting room for chair, otherwise wait in the waiting room chair. If there is someone else sit in the waiting barber chair, so obviously the person that comes at that time, so he is in the waiting state, not fulfilling the state of that customer at the time. So these are the some conditions of the sleeping barber problem. Now what is the solution of that? So we solve this problem by using semaphore. So in this we use 3 semaphores. First is the customer, like as a semaphore. Second is the barber, like as a semaphore, and third is the mutex. The fourth one is a variable. This is not the semaphore. Waiting is a variable. In this particular problem, waiting is a variable. So what the customer semaphore is do? Initially it is 0. Always we take the customer semaphore because there is no customer. So initially we will take 0 for the customer, and initially we will take 0 for the barber also. But what is the working of the customer semaphore, what is the working of the barber semaphore, and what is the working of the mutex? Basically, when this value is 0, that means which count the number of customers present in the waiting room, excluding that particular customer that sit in the barber chair, that is not counted. So in the customer semaphore, initially we will take the value 0. We don't count that particular customer that already sit in the barber chair. So we just count the customers, those are in the waiting state. Now the second thing is the barber. Initially we will take the barber semaphore is also 0. This condition define that that means barber is in idle state, there is no customer at that time. If it is 1, if the barber initially value is 1, it means the barber is in a busy state. When the barber is free, so it is 0. When the barber is busy, then it is 1. So these are the two state. It is 1 at that time, the barber is busy. It is 0 at this time, the barber is free. What is mutex? Mutex just behave like as a lock. It is initially 1. It used for the synchronization. How we use the synchronization in this state? The barber is when the barber is free, then the customer is sit in the barber chair. When the barber is busy, then the customer wait for the barber chair. So these are the basic concept of the synchronization. Then that how the barber at which time the barber cut the hair. So these are the synchronization steps that we used. Now waiting is a variable. Initially it is 0 because we think that there is no customer at the initial time. When the customer is increased, so these waiting state is increased according to the customers. So initially we will take, this is not defined, the customer is 0, that is the semaphore customer is 0, semaphore barber is 0, semaphore mutex is 1, and waiting is 0. Okay. So this is the code for the barber. While true means we always come in the repetitive loop. So wait customer means initially the customer value is 0. That means there is no customer. So barber go to sleep and process preempt to the customer. On wait customers means we have just decrement the customer because the value of the customer is 0. So at this time it is in the blocked state. So customers are blocked because there is no customer. Wait mutex. Initially the value of the mutex is 1. So wait mutex, that means now it is 0. So this is just because this is the structure of Barber. This is not the structure of the customer because there is no customer in the initial state. So Barber either sleep or just lock the shop and this left out. So this is the basic condition of the Barber. When waiting goes to the waiting -1, that means that this particular condition is blocked at this time because initially the value of the customer is 0. And signal Barber. Signal Barber means we just increase the value of the Barber, and the signal mutex, we just increase the value of the mutex. Now call the function cut here. So just move with the structure of the customer. So we start because with the customer of the structure of the customer. Now wait mutex, initially the wait value of the mutex is 1, so now it is 0, but we have just moved with the next state because there is the true statement. If waiting less than chairs, we will take the chairs as 5. Waiting value is always less than the number of chairs. So waiting goes to waiting +1, that means we just increase the value. Initially the value of the waiting is 0, so we just increase the value, that is 1. There is one customer right now. And signal customer, that means we just increase the value of the customer because waiting is increased, then the customer is also value of the customer is also increased. Now the signal mutex, that means another, we will just move with the mutex value. So because the mutex value after the signal is 1, so it is just go with the wait mutex because it is already 1 at this time. Now wait Barber. Wait Barber means initially wait Barber, the value of the Barber is 0 at this time. So preempt to Barber for the haircut because we have the customer at this time. So we just go out with the Barber function and get haircut. After this haircut is completed, then we just move with the get haircut, else signal mutex is high. Signal mutex means the value of the mutex is high. So this is the basic code for the customer. Now the second problem is the bounded buffer problem. This is the producer consumer problem. This is also known as the producer consumer problem. In this problem, there is a one producer and a one consumer. There are two persons, one is producer and other is consumer. And other is three important conditions are there. First is when the producer produces the item. So first check any slot is empty, buffer is empty or not. Empty or not empty. This is checked because if there is no space, then how we have to produce the item and what is the place that we have to put that particular item. So it waits for free that particular state or the slot. Otherwise overflow condition occur. Obviously when the stack is full, then we just produce one or more item, then how we have to put that particular item because the stack is full. So this is the overflow condition. Now when the customer consumes the item, so first check that buffer is, there is any item of item is in buffer or not. So it waits for an item, otherwise this is underflow. When there is no item in the buffer, then how the customer consume the item. So this is the second condition. Now the third is both producer and consumer will occur the event one by one, otherwise a clash occurs. When producer produce the item but consumer not consuming the item, so the buffer is always full at the producer side. When the producer not producing the item and the customer is always consuming the item, so this is also a problem. So these are the clashes. So this process needs the process synchronization. So there are three semaphores in this problem: S equals to 1, E equal to N, and F equal to 0. What is S, what is E, and what is F? S is used for the critical section. At this time, as value of S is 1. E is used for the empty. E means empty, that represent the slot of the buffer, that the buffers are empty or full. When the F is 0, that means it represents the value of full, that define the slot of the buffer are full. So E represent for empty buffer and F represent for the full buffer. If F equal to 0, that means the buffer is full. If E equal to N, that means the slot is free. So just see the code of the producer process. While true, always true for that particular code. Now produce used for the producing the item. Append means we have to just append the buffer. So wait E, the value of E is obviously E is represent for the empty. So when the value of E is 0 at this time, so when the wait signal is E, that means we don't have anything in the buffer and we just reduce the item. So there is no space. When the value of E equal to N represent what? The slot of the buffer are empty. That means at this time the buffer is empty, so just we have to produce the item. So we have to just give the signal condition is high for using the critical section, and when the signal F, that means the one item that we have to produce, that is increased by the producer. Now the consumer process. In the consumer process, we just take wait F. So we just reduce the wait, that means the consumer consumed one item, and wait signal S. So at this time the semaphore critical, because that particular critical section used by the consumer, so that signal is reduced. So that is 1 minus 1, that is 0. So that means consumer consumed that particular item that is produced by the producer. So this is used by the customer. So this is a signal E and signal S for increasing that particular concept. So the solution is what? That we have the 5 items A, B, C, D, E. Wait E means how much empty slots in the buffer. If it is 5, so obviously one by one we have to produce the item, and we just reduce by the wait E. So at this time, first time wait E, that means it is 4. Wait S means the value of the semaphore S is 1 at this time. That produce will use the critical section at that time for the production process. So at that time there is no one interrupt or executing the code at this time, because that section used by the producer at this time. So now the value of S is 0. So there is no anyone come for the production for the item. Now append, used for the appending the buffer. Next prediction. S is used for the increment the value. S value is 1 right now, because this is a signal operation, this is increment. Wait signal reduce the value, and S signal S increase the value. So at this moment customer want to consume that produced item that is produced by the producer. So first item comes in the stack, that item consumed by the customer. Now at the second time the wait value is 3 right now, because wait E at the E value is 4, so it is 3 right now. Same process is done by the A, B, C, D, E 5 times. When the value of E is 0, so that represents that the stack is empty. So there is no item in the stack right now. So what the consumer consumes, so this is the condition of the underflow. This is the basic steps that I write for the consumer and the producer side. Now this is the underflow and the overflow. When E is 0, that means there is no other item that we have to consume by the customer. So this is underflow. When the stack is 5, full is high, that means there is no other item we have to put in the stack. So this is the condition of the underflow. So these are the conditions. Now the next problem is the reader writers problem. What is the problem? Basically there are two things, that is for readers and the writers. Reader only read the data, they do not perform any changes in the data. Writers can perform both the activities, either read or write. Now what is the problem? If the process is in writing state or something we have to write on the file, then another process also write on the same file at the same time, then the system will go in the inconsistent state, because we just put A, someone produce A, B, so these are the inconsistent state at the same time. So this is a problem of the writers. Another problem is that if a process is reading the file and another one is writing on the same file at the same time, so that may also lead a problem, because the process writing on the same file will change the value of the file, but that operation is not possible at this time because no file updation. So we avoid that particular situation. At the same time, we don't read and write at the same time. Now the third thing is that reader and writer both want to come in the critical section, but the reader use the critical section at that time, writer cannot use the critical section. This is the basic problem statement of this particular second problem. At the same time, reader read the data, then at the same time, writer don't write the data of the same file, because this is the problem of the critical section. Now the solution is that in the case of reader, if reader use the critical section at the same instant of time, second reader should be allowed to come the critical section for reading a file, because no clash between read and read operation. There is a clash between the reader and writer, but there is no clash with the reader and reader. In case of writer, if writer use the critical section at the same instant of time, it should be allowed. No other process should be allowed to perform the read or write operation, because this is the case of the writer, this is not the case of the reader. So this is very clarify in your mind. If the reader read the data, then another reader allowed for read the use the critical section, but in the case of the writer, there is no one allowed for the for use the critical section at the same time. So there are two semaphores used for this problem and one read count as a variable. Semaphore write, semaphore mutex and the read count. Semaphore write is initialized to achieve the mutual exclusion property. Semaphore mutex is initialized one that is used to achieve the synchronization between two readers. This is also an important point. If the two readers read the data, but the lines are different, so this is also a problem. So we want to achieve the synchronization at the same state. And the read count is what? It is a variable, it is initialized to 0, that will have to count of the process that are reading a particular file. This is simple. How many readers are read at the same time. Now this is the structure of the writer. Wait write, that means one writer is used to the critical section. So there is, when the one writer used of the critical section, so there is no writer come in the critical section at the same time. When this writer is out from the critical section, then the signal is high. And number of times many writers are used of the same process. Now this is the reader process. Wait mutex, initially the mutex value is 1. So when this reader come in the critical section, read count is plus. If the read count is equals to 1, that means this is the entry operation. Wait write, initially the value of write is 0. So this operation is unfilled, so signal mutex is high. When the read operation is performed, we just write that particular data. This operation is used to check whether it is a last read operation or it is incremented by 1. So this operation used for the readers checking that how many readers are come in the critical section at the same time, and how we have to just synchronize that particular two readers. So these are the process of the reader and writer. Thank you.